Okay, we're going to look at the free response from the practice quiz number 6. Using the graph. The picture may not be clear on your video, but you have your handout to look at the graph. If we look at the picture here, it tells us that it is from the first derivative. Therefore, when we see where the first derivative is positive, that means the original function's increasing. Where it's negative, that's the original function decreasing. And then we'll talk about other attributes in just a minute. Now remember that we are talking about a domain from -3 to 5, so we're not considering the set of the entire graph. At what values of x does the graph of f have a horizontal tangent? Alright, where is f going to have a horizontal tangent? Is going to occur where there is a max or a min. Okay, so the original graph will have a horizontal tangent at a max or a min value. Now, so we need to do a sign diagram of the first derivative to determine where those maxes and mins are. So the critical points on a sign diagram are going to be where that first derivative equals 0. That's going to be -2, 1, and 4. So looking at prior to -2, the first derivative is positive. Looking from -2 to 1, it's negative. Then from 1 to 4, it's still negative. And then after 4, it's back to positive again. Alright, so I'm looking for horizontal tangents where the first derivative will equal 0. That is going to occur at x equals -2. Okay, and at x equals 4, because that's where there is a max or a min. It's increasing to decreasing, there's a max, and then decreasing to increasing, there's a min. So at x equals -2 and 4, that is where f has a horizontal tangent. And the reason we would give for that is where the derivative of f of x equals 0 and changes from increasing to decreasing, or positive, let's just say positive to negative, or negative to positive. On what open intervals is the graph of f increasing or decreasing? Alright, we can look back at this sign diagram that we have. Alright, so f is increasing on the open intervals. Okay, it's increasing, and remember the ends of these are going to be -3 and 5. We're not going past those because we have a limit here. So it's increasing where the first derivative is positive. So from -3 to -2, union, 4 to 5. And you also have to justify your answer. The derivative is greater than 0 there. Alright, so f is decreasing. Okay, it's going to decrease on the interval from -2 to 1, union 1 to 4. That's what my sign diagram says. That's where the first derivative is negative. I'll put the word where. Okay. Alright, let's move on to the last two parts of this. Okay, so C says, on what open interval is the graph concave upward? Alright, so let's look back at this graph we have. It's going to be concave upward where the first derivative is decreasing, because that's where the second derivative is negative. So let me write this out for you. It's going to, f of x is going to be concave up where the second derivative is negative. Now, we have the first derivative's graph. So the second derivative is going to be negative where the first derivative is decreasing. Okay? And that's going to occur, where is that first derivative decreasing? From -3 to -1. And it is also decreasing from 1 to 3. Union 1 to 3. Our reasoning would be that's where the first derivative is decreasing. This is really our reasoning. Okay? All right, now, D says, suppose that f of 1 equals 0. Draw a sketch that shows the general shape of the graph of the function of f of x on the open interval from 0 to 2. So we know that f of 1 is 0, so I know this is true. So I'm going to go ahead and mark it. I'm trying to graph f of x. I've got the derivative here, and I'm going from 0 to 2. All right, so from 0, which is going to be in here, to 2, the function is decreasing all the way across. But let's look at 0 to 2. So here's 0, and then here's 2. Notice at 1, we did not have a sign change. So this indicates at 1, it's changing from increasing to decreasing. So there is a potential for there is a point of inflection there. It changes from increasing to decreasing, so that second derivative would change in concavity. So it's going to look like this. It's increasing, so it's going to be concave up and then concave down afterwards. So the graph would look something like that because, according to this, the original function is all negative from 0 to 2 because the first derivative is negative. So it is decreasing all the way across, but it does change in concavity. So the graph would look like that.